Hey guys! In this video, we'll be talking about 5G and what exactly it is. 5G stands for the fifth generation, as in the fifth generation of mobile network. Every generation of mobile network becomes faster and more reliable, promising to change our lives in various ways. The first generation from the 1980s delivered analog voice, while the second generation in the early 90s introduced digital voice. The third generation of the early 2000s brought mobile data and email to our phones, while the fourth generation of the 2010s ushered in the era of mobile broadband with rideshare apps and video streaming. But what makes the fifth generation so special? Well, 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. Today's mobile users want faster data speeds and more reliable service. With 5G, users should be able to download a high-definition film in under a second, with engineers and scientists hoping these networks can boost the development of other technologies, from autonomous vehicles and virtual reality to an expanded Internet of Things. 5G wireless technology is meant to deliver higher multi-gigabyte per second peak data speeds, ultra-low latency, and massive network capacity, which allows for more reliability, increased availability, and a more uniform user experience for every user. But what do any of these terms really mean? Well, first, 5G's high bandwidth, which is the maximum rate of data transfer across a given path, offers the ability to easily transfer any weight of data. While 4G only allowed for 200 megabits per second of data throughput, or the rate at which the data is processed, 5G can provide 1 gigabyte or more, that's 1,000 megabits or more per second. 5G's low latency refers to its ability to respond quickly when asked to transfer data. While 4G suffers from 100 milliseconds in response delay, or latency, 5G reaction time is as low as 1 millisecond, which makes everything happen virtually instantly. Third, 5G's dense connections allow it to connect to 10 times more than the amount of devices in a given square kilometer than 4G. But how can a 5G mobile network achieve all of this? Well, as more people and devices consume more data than ever before, we remain crammed on the same bands of the radio frequency spectrum that mobile providers have always used. That means less bandwidth for everyone, causing slower service and more dropped connections. If we could transmit signals on a whole new band of the spectrum, one that's never been used for mobile service before, we could free up space for more data transfers. 5G will bring wider bandwidths by expanding the uses of spectrum resources from sub-3 GHz used in 4G to 100 GHz and beyond. 5G can operate in both lower bandwidths, such as sub-6 GHz, as well as millimeter wave, which are 24 GHz and up. That will bring extreme capacity, multi-gigabytes per second throughput, and low latency. Specifically, the millimeter waves vary in length from 1 to 10 millimeters, which use higher frequencies than the radio waves, that have long been used for mobile phones and measures tens of centimeters in length. Millimeter waves are broadcast at frequencies between 30 and 300 gigahertz, compared to the bands below 6 gigahertz that were used for mobile devices in the past. There is one major drawback to millimeter waves, though. They can't easily travel through obstacles or buildings. That's why 5G networks will likely enhance the traditional, more familiar cellular towers with another new technology, called small cells. Small cells are portable miniature base stations that require minimal power to operate and can be placed every 250 meters apart. To prevent signals from being dropped, carriers could install thousands of these stations in a city to form a dense network that acts like a relay team, receiving signals from other base stations and sending data to users at any location. Having more stations means the frequency that one station uses to connect with devices in one area can be reused by another station in a different area to serve another customer. What's more, the antennas on small cells can be much smaller than traditional antennas, making it even easier to stick cells on accessible places like light poles and atop buildings. Many more antennas also allow 5G to take advantage of another new technology, called massive MIMO. Today's 4G base stations have a dozen ports for antennas that handle all cellular traffic, 8 for transmitters and 4 for the receivers. But 5G base stations can support about 100 ports, with more antenna fitting on a single array. That capability means a base station could send and receive signals from many more users at once, increasing the capacity of mobile networks by a factor of 22. This technology is called massive MIMO, or multiple input, multiple output. MIMO describes wireless systems that use 2 or more transmitters and receivers to send and receive more data at once. However, installing so many more antennas to handle cellular traffic also causes more interference if those signals cross. That's why 5G stations must incorporate beamforming. Beamforming is a traffic signaling system for cellular base stations that identifies the most efficient data route delivery to a particular user and reduces interference for nearby users in the process. The primary challenge for massive MIMO is to reduce interference while transmitting more information from many more antennas at once. At massive MIO base stations, signal processing algorithms plot the best transmission route through the air to each user. Then they can send individual data packets in many different directions. By choreographing the packet's movement and arrival time, beamforming allows many users and antennas on a massive MIMO array to exchange much more information at once. Beamforming can also solve a problem for millimeter waves, namely the problem that cellular signals are easily blocked by objects and tend to weaken over long distances. In this case, beamforming can help by focusing a signal in a concentrated beam that points only in the direction of a user. This approach can strengthen the signal's chances of arriving intact and reduces interference for everyone else. Finally, the high throughput and low latency characteristics of 5G are achieved through a technology called full duplex, which modifies the way antennas are able to deliver and receive data. With 5G, a transceiver will be able to transmit and receive data at the same time on the same frequency. To achieve full duplex in personal devices, researchers must design a circuit that can route incoming and outgoing signals so they don't collide while an antenna is transmitting and receiving data at the same time. This is especially hard because of the tendency of radio waves to travel both forward and backward on the same frequency, a principle known as reciprocity. One drawback to full duplex is that it also creates more signal interference through a pesky echo. When a transmitter emits a signal, that signal is much closer to the device's antenna and therefore more powerful than any signal it may receive. Expecting an antenna to both speak and listen at the same time is only possible with special echo canceling technology. So now that we understand what is 5G, what can we do with it? A defining capability of 5G is that it's designed for forward compatibility, the ability to flexibly support future services that are unknown today. But we can already see where 5G's applications will also be the most beneficial, such as through enhanced mobile broadband, where in addition to making our smartphones better, 5G mobile technology can usher in new immersive experiences, such as through VR and AR, with more faster, more uniform data rates, lower latency, and lower cost per bit. Or mission control communications, where 5G can enable new services that can transform industries with ultra-reliable, low-latency links like remote control of critical infrastructure, vehicles, and medical procedures. And even massive IoT, where 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything, with the ability to scale down in data rates, power, and mobility, providing extremely lean and low-cost connectivity solutions. However, to access the new 5G mobile network, we will need new phones, tablets, portable hotspots, with a 5G radio inside to connect to the new 5G networks. Therefore, current 4G and 4G gear cannot tap into this network. But 5G is already here today, with global operators launching new 5G networks in early 2019. There are several new mobile phones available that are designed to support 5G, and multiple carriers across the world support the 5G wireless network. However, as with previous generations of mobile networks, it will take time to proliferate the new 5G network to make it available to more people. I hope this video helped you to learn more about 5G and what it is.